Modeling with quadratic functions is section 2.4. So we're going to look at 3 different ways to write quadratic equations and how we can use them to answer some questions. So when writing a quadratic equation, when you're given a point and the vertex, h of k, use the vertex form y is equal to 8 times x minus 8 squared plus k. Example 1. The graph shows the parabolic path of a performer who is shot out of a cannon, where y is the height in feet and x is the horizontal distance traveled in feet. So we want to write an equation of the parabola, and we're going to use vertex form. So if you look here, I know it's showing 3 points, but there's only 2 points where they're giving us an answer. All right. So on this last one here, we'll probably be using that for one of our one part of our problem. So we're going to use the vertex form. All right. So our point is at 0 and 20. And our vertex is at 25 and 30. So now we're going to plug that into our equation. So we're going to have 20 is equal to a times our x value is 0 and then we're going to minus our vertex is h, so we're going to say minus 25. And then we're going to say plus, and then our k is 30. All right? So now what's going to happen here is I need to solve for a. That's the only thing I have there. All right? So think about this. I'm going to move this 30. I'm going to move it over to the other side. So 30 minus 20 minus 30, excuse me, it's going to give us a negative number. In fact, we can write this as a times 0 minus 25. Notice I forgot the squared there. Squared is equal to negative 10. All right, now I'm going to tell you 0 minus 25 will be negative 25. Negative 25 squared will be 625. So 625a is equal to negative 10. And when I divide that, negative 10 by 625, I'll get negative 0.016. Okay, so our equation then will be negative 0.016, y equals, so now I'm just plugging in that a that I had and my h and my k. So I have x minus 25 squared plus 30. And notice this time here, they gave us a restriction on the domain. And on this case here, it should actually make sense because here's where our cannonball performer starts, and here is where he ends. Well, he gets shot out of a cannon, not a cannonball. Well, you could do a cannonball if you wanted to. All right, so that is why our domain is restricted there. That's our x values, remember? So from 0 to 60. Because if he went farther, he could actually just splat. All right, so the performer lands in a net 60 feet from the cannon. What is the height to the nearest foot? So on that one there, all we have to do is plug in our x is equal to 60, and that will give us our height. So y is equal to, again, negative 0.016 Then I have 60 minus 25 squared plus 30. You can plug that in your calculator exactly the way you see it. You'll find out that y is going to be 10.4. So the height of the net is about 10 feet. And if you look back up there real quick, it does look like it's about 10 feet, right? So our y value is about 10 feet, our x value is 60. So that kind of makes a good sense there. So let's go ahead and say that's my final answer. I'm all done. Number 2. So again, remember what we're doing is when we're writing a quadratic equation, the first time we were given a point in the vertex. The second example here is when we are given a point in the x-intercepts. Remember, when we have the x-intercepts, we are going to use our x-intercept form, where y is equal to a times x minus p times x minus q. So example 2, a meteorologist creates a parabola to predict the temperature tomorrow, where x is the number of hours after midnight and y is the temperature in degrees Celsius. Now think about that. That is going to be 24 hours from midnight to midnight. We'll see why I'm saying that in a second. All right. A, write a function that models the temperature over time. What is the coldest temperature? And write an equation of the parabola that passes through the point 0 and 6.3 and has x-intercepts 6 and 21. So P is equal to 6, I just told you that. And Q is equal to 21, and I told you that our point is 0 and 6.3. So if you think about it, there's our point. The other 2 points that they gave us are the x-intercepts. And we do have another point here, but like I just said on the previous one, and I'm telling you all of that when my base is in the way, that point, well, we don't know what it is. We know it's 24 right now because I told you that it's going to go from midnight to midnight. So I know at least my x value is 24 there. All right. So what we need to do is we're going to write our function and we're going to plug in everything. So we are going to take our 0. And let me use my pencil. So we are going to use 0 is equal to, again, we don't know what our A is. And let me go back and say this right because I'm not gonna, I've already restarted this once because my pencil quit. So I don't want to do that again. So I'm gonna just tell you, I made a mistake there. My Y value is 6.3. So I need to go back to my Y value, which is 6.3. So I'm going to say 6.3 is equal to, again, here's my A, and in this case now, our X value was 0. So I'm going to say 0 minus, well, my P is 6 there. My other one is 0 minus, my other x-intercept was at 21. All right, so now I'm going to do the same thing here. I'm going to have 6.3 equals, I'm going to have A, but negative 6 times a negative 21, negative times a negative is a positive, and 6 times 21 is 126. So now to solve for A, I'm going to get that by itself by dividing by 126, and that will give me that A is equal to 0.05. Okay? Then our Y, we're just plugging in what we just said here now. So we're going to write our equation because that's what it asked us for first. So my equation is Y is equal to f of x. Again, we're going to see why I said that in a second. And it's 0.05 times x minus 6 times x minus 21. All right, so now what we have to remember is our coldest temperature is at the vertex. So remember, on a vertex with this, you had to find your x value, your axis of symmetry. We know it's going to be somewhere around here somewhere. All right, our axis of symmetry. Well, how did we do that when we had our x-intercepts? Well, remember, all we did was we said that x is equal to our p plus our q divided by 2. So in this case, it's going to be 6 plus 21, and that's going to be divided by 2, which will give us 13.5. And then we're going to plug in that 13.5 into our f of x. So we're going to say it's 0.05 times 13.5 minus 6 times 13.5 minus 21. And when we work that out, we'll find out that our coldest temperature is at negative 2.8125 degrees, and that was in Celsius temperature. All right. So that's not too bad. And again, that's going from midnight to midnight, so that is 24 hours. That is our 24 hours is here. All right. So now, why do I keep saying that it's 24 hours? Because on the second part, it's saying what is the average rate of change on the interval in which the temperature is decreasing and when it's increasing, and compare the two average rates of change. All right. So what we're going to see here, what that means is somewhere along the line there we had our vertex, and our vertex is at 13.5 and negative 2.8125. Okay, so now what the average rate of change is really just our slope. So what we're looking at is we're kind of looking at from going to 0 to 13.5. Again, if you think about it, that's when our parabola is decreasing, and then we're going to go from 13.5 to 24. Those are my x values, and that would be when it is increasing. Okay, so knowing that here, let's go ahead and do this. So our average rate of change is our f of x 2 minus f of x1 over x2 minus x1. which again was just our slope, ladies and gentlemen. So let's go ahead and do our decreasing first. So if I go and do my decreasing, remember it is decreasing our average rate of change. I'm just going to say ROC for rate of change right there. Okay. And we're going to see that is over the interval from 0 to 13.5. So now I'm going to plug in that just like it said. So f of 13.5 minus f of 0 over 13.5 minus 0. All right. So remember at 13.5, that is our x value. Our y value is negative 2.8125. So I'm going to say that it was negative 2.8125. And I'm going to subtract, well, when f of 0, what is our y value at f of 0? It's 6.3. So I'm going to subtract 6.3, and I'm going to take and get 13.5 on the bottom, because 13.5 minus 0 is 13.5. All right, if you work that out, we are going to get negative 0.675. Now, when we're comparing rates of change, we need to make it positive. So to make that positive, I'm just going to take the absolute value of it, and that will give us that it's equal to 6.7, 0.675. All right, so now we're going to do it for when we are increasing. Our increasing rate of change. So on that one there, we're going to do f of 24 minus f of 13.5. And then we're going to go from 24 to 13.5. Again, look at how I chose my x1, y1, x2, y2. All right, that's all we're doing. So same thing that we've done before. So now you're going to say, but I don't know what f of 24 is. Well, all you have to do is take that 24 and you're going to plug it into your equation here. Right? You're going to plug it into your equation. Like I said, last time I did this, it was starting to not let me finish. So I'm just going to tell you that it's 2.7 when you plug it in, and it's going to be minus a negative 0.28125. And I barely got that in there. And then 24 minus 13.5 will give us 10.5. All right. So if we work that one out, we will get 0.525. All right. And now it wants us to compare those two. So they are both positive, and it looks like what we're going to have to say is, well, which number is greater? Well, this number here is definitely greater than this number here. So when they're asking you something like this, and I'm not sure if they're going to ask you on a test, that's kind of why I'm still going to go ahead and do it. But what we can say is that the average rate of change at which the temperature decreases And again, that would be from midnight to, well, take midnight and add 13.5. Well, 12 hours to 12 hours would be 12 p.m. And it says I went 1.5 more from that, right? Because I have 13.5 there. So that would be 1:30 p.m. is greater than its increase from 1:30 p.m. to, well, basically our next midnight. All right, people, I made it. I'm almost done. Now, last one, if we're given 3 or more points, what you can do is use your graphing calculator, make a list, and from the list, make a scatter plot. And if it looks parabolic in shape, use quadratic regression. All right? So remember, on this one here, we will use for our equation, we're going to use y sub 1. For our regression, we're going to have that. And then we're going to say a sub x1 squared plus b sub x1 plus c. All right, so we're going to go do that real quick here. I do have it set up for us. I have our table. Remember, go up here. That's where you're going to put in your table. And I made sure that I kept it so that you can see. Well, you're going to say, well, I can't say anything. Well, that's because these are all big numbers. That's why we're going to hit that plus sign there to zoom fit. And if you look there, it does kind of look like it's going parabolic. It looks like it's going with a maximum up here somewhere. All right. So just remember, we need to do that. All right. So once I do that, remember, I just showed you what we're going to do. So we're going to put y. And remember, go to this ABC to see this here. And we're going to put 1. And then tab it, or move your arrow. Get your regression symbol there. And then we're going to say A. And then we're going to say X. And I don't think it matters which one you put first. Well, let's see. I know that the last time I put the squared when I was practicing. So let's see if I put that there. And let's see if I go back to the other one. And I want to square it. Yeah, it looks okay. Then we're going to go plus. And then we're going to do B. Not a square. I don't know why that came up. I'm going to do B. We're going to do, oh look, it's already doing a little parabola shape there for us. X. And again, sub 1. Oh, look, that's a very nice looking parabola there we got. And then we're going to do plus. Plus, not equals. Right, so as you can see, it kind of looks like it's close to it. Remember, it's got to be a line of best fit. And same thing here now. If you look at it here, I'm going to get rid of that. Now this time we have an r squared. If an r squared is close to 1, then we know it's a good graph. So this one says it's a pretty good graph for the data that we have. So let's go back to our screencastify here. And all right, I told you to give me a second here. I'm trying not to have to redo this. All right, and I got so close, people. I got so close. All right, so now you can kind of see what I'm having to do here. Yeah, you're going to learn something. So I need to go to my Bluetooth, disconnect my pencil. Come on, disconnect. There we go. So forget this device. Now I'm going to go and plug it back in. We'll see that it'll say parrot, hopefully. Yep. Now if I did this right, yes. All right, you just learned what I'm going through here. So with what we just said, if we go back there, so look at it real quick. Okay, if we look at it real quick there, look at what our A is, what our B is, and what our C is. All right, so I'm going to put those in. And we will see that our Y is equal to negative 0.015x squared plus 1.56x minus 10.9. All right, so now kind of look at what I just did there. All right, so when with our C value, I just took a 1 decimal place. With my X value, I went up to 2. When I went to my X squared, I went up to 3. That's just a kind of standard that they kind of do here. And then they are asking us, what is our optimal driving speed? So our optimal driving speed is, if we go back to here and we see what is our optimal driving speed, is going to be our maximum this time. And if you look at it, it's 50.843. So you're going to tell me that our optimal driving speed is about approximately 51, and that would be miles per hour because we were looking at our value there. Okay, 51 miles per hour. All right, and just real quick here, again, remember what I just told you, that the R squared is important to us, and it is the coefficient of determination. And again, the closer R squared is to 1, the better the fit. All right, people, thanks for putting up with that little glitch there. But at least I got it done, and it looks a lot better than my writing with my finger. Thank you.